This system for organizing our marbles that we've been talking about in this last couple videos and pages is effectively the same idea that is used for mathematics all over the world, both humans and computers. The essential idea is that we keep making larger and larger packages where every time we have a fixed number of packages of one size, we put those together into a single package of a larger size. So if we're using a one-handed system, we every time we have a handful of marbles, we put it into a small package, and a handful of small packages becomes a medium package, and so on. A handful of any collection of packages that are all the same size will be put together into a larger package. That's that kind of packaging scheme, larger and larger packages, is the same idea used all over the world, with the only difference being the package size. Human beings generally have tended to use a two-handed system instead of the one-handed system that we've been talking about. And computers don't have hands at all, so they use an entirely different package size. We'll talk about that in a minute. But let's talk about the case with human beings and the kind of math that you learn in school and the kind of math that people do on paper and by hand, so to speak, and rightly so. Because human beings have fingers and it's easy to count on our fingers, we have tended to use systems that are based on our fingers, and at some point along the way, makes sense, I guess. Humans decided they'd just as soon use both hands instead of just using one hand, so fair enough. You can package your marbles based on a two-handed system instead of a one-handed system. Every time you've got enough marbles to fit on all the fingers and all the thumbs, both thumbs on both hands, we're going to package those together into a small-sized package. So here we have one handful of marbles, and here we have another handful of marbles, and so here we have a handful for marbles in both hands, two handfuls. Both hands are full of marbles. We package that together into a small-sized package, and then the idea is just going to continue from there. Every time we get enough of these small packages to fit one of these small packages on all of our fingers and thumbs on both hands, we package them to all of those together, those small packages, into a medium-sized package. And every time that we have enough medium packages to fit on all the fingers and thumbs on both of our hands, we package those into a large-sized package. And whenever we have two handfuls of large packages, we get an extra large package, and we could continue on from there. We can do the same thing then that we did as far as simplifying our notation, now just under the understanding that we're working with a two-handed system rather than a one-handed system. We can again take this. Here we've got a medium-sized package which has two layers of packaging, and we can simplify that as this, and there's only one medium-sized package. And here we have all of these guys. We don't have enough small packages to make another medium package, so we just write this. We have this many, and even if we didn't know, numbers for counting, there's a small enough number of small packages here that we could keep track on both hands, and we could say, yep, the number of small packages here is the same as the number of dots we've drawn in here. It's 7 for those who know how to count. 1, 2, 3, 4, 5, 6, 7 dots. 1, 2, 3, 4, 5, 6, 7 small packages. But again, even if we didn't cheat and use the numbers that we already know, we could just use our fingers and match up, okay, how many fingers does it take to describe these packages, and that's the same number of fingers I'm going to use to describe this number of dots. And how many dots do I have left over And I'm going to draw the same number of leftover dots here. So once again, this time you have to realize we're using a two-handed system here instead of the one-handed system that we used before. If I drew this picture to describe how many dots, then how many marbles I had, then under a two-handed system, this picture describes this many dots. Again, it's a very concise, this down here is a very much more concise, smaller, easier notation than having to draw or count all of these dots up here. Now we're going to move on and talk more about this two-handed system and possible improvements or changes to it to get it more in line with the system that we're actually used to. But before we go on, to see if you understood what I've tried to describe here, who can tell me, without counting all of the dots up here, just based on this symbolic notation down here, can you tell me how many marbles we have? How many marbles do we have up here just based on looking at this picture down here?